the focus of this lesson is on using the intermediate value theorem to find the roots or zeros, another name for roots, of a polynomial. So I'm going to go ahead and just draw a Cartesian coordinate plane to kind of give us some perspective of what this intermediate value theorem is saying. But it says let a and b be two numbers where a is less than b. So basically a is less than b, or to the left of b on the number line. If f is a polynomial function such that f of a and f of b have opposite signs, then there's at least one number c where c falls between a and b, for which f of c is 0. So that's a lot of math symbols, and you might want to pause to kind of process what that stated, but I'm going to kind of explain also what that stated. So again, a is less than b. They could both be positive, they could both be negative, one could be positive, one could be negative. It doesn't really matter. So I'm just going to pick a place for a to b, and I'm going to pick another place for b. Okay, you can see a is less than b because it's to the left. And then I'm going to draw on a curve that represents f, and it's a polynomial function. And the significance of a polynomial function and why we can use the intermediate value theorem is that we're dealing with a continuous curve. Polynomial functions are continuous, meaning if you start, let's say, from the interval from a to b, and you were to draw the graph, you never pick up your pencil because it's continuous. That's what a polynomial is. So maybe it looks a little like this, but that could be your interval. Now, the thing is, they said they wanted f of a and f of b to have opposite signs. The way I just drew this in, this is f of a, and we can see that it's above the x-axis, so it has a positive sign. And we can also see that f of b is also above the x-axis, so it has a positive sign. So those are not opposite signs. So what this is talking about is if you have the case where you have an a and you have a b, and you have that smooth polynomial continuous curve, and your f of a and your f of b take on opposite signs. So in other words, one point is below the x-axis and the other is above, and I could have switched that around to be vice versa. In that case, it says if you have a smooth continuous curve, then what happens is you're guaranteed to cross the x-axis and get an x-intercept, aka root, aka 0. So those all mean the same thing, and that's the value c that they're talking about. It falls between a and it falls between b. So that's guaranteed to happen. So that's important, and that's hopefully gives you some conceptual of the intermediate value theorem here. Now let's go ahead and take a look at an example where we want to apply the intermediate value theorem. So it says find the real zeros to two decimal places in the specified interval using the intermediate value theorem. So they give us the function f of x equals x to the fourth minus x cubed minus 10, and it's on the interval, closed interval from 2 to 3. So the way you would go about using the intermediate value theorem is, well, we can kind of draw this, I guess, initially just to kind of give you some more insight. Is we know that at f of 2, if we were to plug that 2 in for x, we would end up with 2 to the fourth minus 2 cubed minus 10, which is just negative 2. So when x is 2, we get negative 2. So that's the point 2, negative 2. And you can kind of think of this 2 as your a and this 3 as your b, just FYI. And notice your f of a is taking on a negative value. Just keep that in mind. And then you have your f of 3, which if you plugged it in, you'd get 3 to the 4th minus 3 cubed minus 10 is a 44, which is somewhere way up here somewhere. And that f of 3 took on a positive value, 44. That give you a height of 44. So by the intermediate value theorem, it says that between your interval of 2 to 3, there should be a value that is your root, or that is your 0, because your endpoints, 2 and 3, had opposite signs, so that you're guaranteed. Now let's go ahead and take a look at how we would use a graphing calculator or some other graphing device to help us get at what the 0 would be to 2 decimal places. So what we would do is, again, on a graphing calculator you could use the table function, or you could use Desmos here, but you would want to determine, okay, basically your endpoints. You want to figure out what is f of 2, which we already did, but we'll just do it again. You can see f of 2 is negative 2, and then you would figure out what's f of 3. And you can see if you do f of 3, it's 44. So you know your 0 falls somewhere between 2 and 3. And so then what we could use is what's called like the bisection method, which is finding the midpoint between 2 and 3. So in this case, it would be 2.5. And to kind of break the interval down, so we get closer and closer to the 0. And so what happens when you do f of 2.5, you can see you get a positive value. So now, which interval are you looking between? Are you looking between the midpoint in 3 or the midpoint in 2? Well, since the midpoint gave you a positive value, you want to compare it between the one that gave you a negative value, because remember, the 0 falls between the different signs, the opposite signs. So our 0 falls between 2 and 2.5. So halfway between 2 and 2.5, let's go ahead and do that, would be 2.125. And so when you calculate that, you do get a positive value back. That's actually getting you closer to 0, by the way, if you notice that. So we are getting closer. So it's positive. So I want to compare that now between 2.125 and 2. So somewhere between those two intervals, I believe, would be our 0, because again, that one takes on a negative sign, this one takes on a positive sign, and again, we're getting closer and closer to 0 with our values. So somewhere I need to go about halfway between. Now with the bisection method, you could be completely perfect on your bisections by adding up the values and dividing by 2, but at some point that gets a little tedious, and I kind of don't be perfect about it. And so I'd be like, okay, well, this is 2 and this is 2.12, so 2.12 if you will. And so about halfway would be 2.06. So maybe that's what I would check next. And you can see when we take our function evaluated at 2.06, we get a negative value back that's even closer to 0 than what 2 was, because it gave us a negative 2 back, whereas this one gave us negative 0.73 back. So that's even closer to 0. So this is the negative that's closest to 0, and this is the positive that's closest. So now I'm in between the interval of 2.12 and 2.06. So about halfway between those would be 2.09. Oh, and I can see that that takes on a negative value that's even closer to 0 than 2.06 was. So now I know that I'm between 2.09 and 2.12. And so you could pick maybe 2.10. And you can see that gives you a positive value back. So 2.09 gave you a negative value, 2.10 gave you a positive value, so you know you're somewhere between 2.09 and 2.10. The debate is on which one are you closer to, because that's going to be your answer at the end of the day to do decimal places. So I would pick immediately like in the middle at 2.095. And I would see that that gave me a positive value back that is even closer to 0. So now I can see that I'm between 2.09 and 2.095, so somewhere between there. So something smaller than 2.095, so therefore I'm going to round to 2.09. So at the end of the day, my root, my 0, is 2.09. So this is showing you with kind of using your graphing calculator and a chart. And I know it's not conceptual because I'm not drawing you an image every single time, but the one nice thing is you can kind of see here, we were trying to find the 0, but if you look at the graph for our function, because this graphed it, and you click here at the 0, you can see that it's 2.09, and it goes out further to the thousandths place too. But to the hundredths place it's 2.09. And so that is how you find a 0 using the intermediate value theorem and the bisection method. And again, I didn't perfectly do the bisection method, but you get the general idea of how it works. And then if you do want more of a graphical conceptual of what were we doing when we were picking between which two values to break down and to get a midpoint, there I posted another video to kind of give you more insight there.